All right.
Okay, so you had something to ask.
Yeah, I started watching Jurg's video on making data types in beta. And then I went to Gamma and I was going to make a data type. And then I searched for the template object and it didn't exist. So I think you have to use record. Is that correct?
Yeah, that's one of the ways.
Can we make some?
Yeah, sure. I guess if you come from programming, then you have an idea of mutable and immutable.
Yeah.
Because that's used quite often in Gamma to differentiate things.
Why are some things mutable and some things immutable?
So all of the main libraries and the most standard approaches are using immutable data types because of the data flow approach.
Mm-hmm.
If you didn't have immutable data types, then branching it out in two branches, you would end up mutating the data in a way that you don't expect.
Yeah.
You have record, and then you also have a class, which is a mutable object. So you can choose from these two to make your data types. In the end, both is a data type you can define, just one is mutable and one is immutable. The record is the more standard one, the immutable. Anyways, so in the definitions, I just double-clicked here and wrote record, and I can create a new record with any name. Camel case is the standard way to name things in Gamma. So it's just another patch, but you can define operations and fields which are called paths in Gamma, and they then contain your data of the data type. So let's say we were making some particle and it has some position. I can just write position and I want a path. And you can have generics, but you can also declare the type, the specific type. And let's say here we want vector 2, which is a two-dimensional vector. Already the data type contains it, but there's no way to access it. If you select it and press Ctrl-K, it's a quick shortcut to create the standard input for the create operation, which is VL's constructor, basically. Mm-hmm. It also creates output for the split operation, which is the standard way of getting the data out. You can also create your getters and setters and extra operations, but this is usually the base that most records have. So what is the position and position at the top and bottom? Yeah, so getters and setters. In a way, it's getters and setters, but it's much more generic than that. It's this is an input into the patch, and this is an output outside of the operation. So any square that has a thing coming in there is then outputting outside. So it's an output, and the other one is an input. In use, then if I went to the application patch, double click and find for the any name data type. Then you get the create and split operations. Those are the operations that are defined. And there you can see which inputs and nodes belong to what operation depending on the color of them. So it's all color coded. Here you can see the create is white, the split is blue, that's standard colors, and any other operations that you add get a new color, and that way you can tell. It's like all operations are on the one patch. It's up to you if you split them spatially somewhere or you just put everything together because it's operating on the same data. And a third standard operation is update. That's usually, if you have something that runs every frame, then you want to have an update operation, and that's gray. So we have the create, and this is the initial position. And on the output, I'm getting an instance of the data type that we declare. And if you want to do anything with that, you're using again the operations of the data type. So I can use the split that was generated with the Ctrl-K, and here again I get the position. Can you go over the difference between create and split? So create is a constructor. It creates an instance of your data type. You can pass it around. You can run operations on it. If I add some update that, let's say, adds some given offsets to the position, you can just add plus here. And if I hold Control and press, it creates an input and another input. You can also just write input, and I can assign this to update. So now you see this is gray, and this is part of the update operation. The result needs to be saved somewhere because the position is immutable. All the standard data types of VL are immutable. So taking the position and adding to it doesn't change the actual field in any way. It just creates a new position with the offset. So I need to save it again in the pad.
Mm-hmm.
This way now if I use it in the application patch, you can double click on a link to create a node on it.
Yeah.
I added the update, but I'm not giving any offset. But now if I give something here, it will offset it. But since everything happens on update, not going anywhere, all of this patch happens on each frame. It creates a new AnyName instance, then updates it, and reads out the result. If you want to keep state of the AnyName, then it needs to be saved to a pad, so it's retained between frames. If I'm holding Shift, it creates a pad, call it the particle. Now pass this in here, but still it's all on update. Now if I assign the create to the create of the application, so meaning that it runs only at the very start of the patch, then it will create a particle and keep updating it. But again,
I see. So when you initially make it, it's constantly remaking itself. So
yeah, if it's in the update operation, then it constantly keeps creating a new one.
Yeah.
Sometimes that's something you may want, sometimes not, and you have the freedom to decide what runs on the initialization, what runs in at different times, create different operations, and then call them. But again, it's just the one particle operates on it, creates a new copy of it because it's immutable, and doesn't save it. So it's still not flowing. But if we save the updated particle, we actually retain the state, and now we have the particle changing over the course of the program.
Nice. Awesome.
If I did the same, but made it mutable by changing it to a class.
Oh, I see. That's where you do it then.
Let's say I copy it here, create particle mutable. Then I would have the update on the mutable particle, and also I need to split. So now if I put this here, then even without saving it, again, it changes the contents because it's a mutable data type. So this actually mutates the original particle. There's a reason there's both. There's approaches where this is more appropriate. When you're really just working on the data flow approach, you're going top to bottom, branching out. And this mutable approach, when you just have storage of objects and you want to actually just run some operations on them, and you want them to keep their own state. And also for performance reasons, it's of course more performant to not copy some complex object each time it's mutated. It depends. So you have both choices here.
Thank you.